Okay, here we go. 4.2b, max-min problems involving quadratics. We just got done with 4.2a, which is linear and quadratic functions. Now we're going to take a look a little bit more about quadratics and a little bit more of the application of quadratics. There's not a lot of notes. This screen really has most of the notes, and really we're going to jump into some problems, and hopefully it'll make sense with what we have up on the screen right now with the problems that we're getting ready to take a look at. Now, anytime you deal with applications, one thing that you might consider, if possible, is drawing a picture. Now, that's not always the case, but if you can draw a picture of the scenario, sometimes that visual aid gives us a little bit of assistance, and that helps some of us. And so if you can draw a picture, try that. That may help. Really, the big parts of this are going to be right here. The first thing we want to do is identify what we call the primary equation. Now, the primary equation is what you're trying to find the max or min of. So if they say, I want you to find the maximum area, then the area is going to be the primary equation. If they say, find the maximum perimeter, then we want the perimeter is going to be our primary equation. If they want to find the maximum profit, then the profit's going to be our primary equation. So whatever they're trying to find the max or min of is what the primary equation is. So we're going to have two equations here. One's called the primary, and the second one's called the secondary. Okay? The secondary equation is the equation that we know something about. The primary is usually where we don't really know anything about. We have two unknowns, two variables. We don't want two variables because we really just want one variable to make a quadratic out of. And so we use the secondary, once we find it, and we put it inside the primary so that hopefully it eliminates a variable and we can have a quadratic, which is what we're trying to achieve. So how do we go about doing all that? Well, what you do first is you isolate a variable in the secondary equation. So let's say the secondary equation is x plus y equals 50. Well, what I want to do is I want to isolate one of these two variables. A lot of times we'll just isolate the y by subtracting 50, or excuse me, by subtracting x. And so now we know what y is. It's 50 minus x. Now, why would that come into play? Well, if our primary was, let's say, xy, let's say it's an area of something, area of a rectangle or something, and it's xy, and this is, let's say, some type of perimeter. It's not, but let's just say it would look something like that. Then what we can now do is we can substitute in 50 minus x, something that we know something about. This is called the secondary, back into the primary. The primary is what we're trying to find the max or min of. And so we take this value and replace the y. And what you'll notice is y of x times 50 minus x. And if we distribute, we end up getting a quadratic. Okay, now, so that's sort of what we're trying to do is isolate a variable in the secondary equation so we can substitute it into the primary equation. And this should result in a quadratic equation. Now, what's so important about a quadratic? Why are we dealing with quadratics? Well, max and mins always occur at the vertex of the parabola. Let's think about that. If we have, let's say, a concave down, didn't we call this right there the top of the top? It is an extreme. And then what you have is you have the bottom, okay, right down here, and that's an extreme. This value right here is the highest value we can get. So the x value that produces it, and we have a y value that is the max. This is a max. This one, you can look at it, would be sort of the reverse, where we had x value that produces a minimum value. And so with quadratics, what we end up producing is max and mins, these extreme values, and they always occur at the vertex for these quadratics. And so that's what we want to do is we want to find the x value of the vertex, because that's what makes the max or min, and the y value of the vertex is the max or min. Now this is tricky, but what we want to do is we really want to read the question very carefully, because if they say, what is the maximum profit, then we're looking for the y value of the vertex. If they're saying, the y value of the function, okay, so the function's value, the x times y or whatever it is. And if they're asking for how many items must you sell to make a maximum, we're talking about what makes it. We're talking about the x value of the vertex. Okay? And so you need to know what they're asking you to find. So read the directions. Make sure you know what they're asking you to find. Then what we want to do is we want to identify the primary, which is what we're trying to find the max or min of. And then the secondary, they should give us some more information so that we can use it. So the secondary is what we know something about. And then what we can do is use it and isolate a variable, plug it into the primary, so hopefully we would get a quadratic. Now, not seeing a problem worked out, it makes it a little bit complicated. So we're gonna work through problems, but I'm gonna go through these every time we go through a problem. I'm gonna go through, okay, what are they asking us to find? Are they asking us to find the x value of the vertex, or are they asking me to find the max and min? Are they, what is our primary equation and what is our secondary equation? So let's look at some examples. Looking at the first one here, it says determine whether the following function has a max or min, or neither. If it has a max or min, make sure to specify, find that value. So in other words, find the value it is and where it occurs. And so what it's asking for is what is the max and min and where does it occur at. In other words, the x value is where it occurs. Okay, reduce all fractions to the lowest term. So here we go. Here's a function. So this isn't really a word problem, but we're going to see this whole thing in action. So first off, a little review. What we have here is we've got a function, negative 3x squared minus 3x minus, in this case, 106. And they want us to know, does it have a max or min? Okay, well, just look at the a value. Okay, remember the a value is negative, which means frown face. Does frown face produce a max or a min? Well, hopefully what you notice is it's the maximum. It's the top of a hill. It's a peak. It's an extreme max. It's up here. And so this is a maximum. If the a was positive and we would get a U shape, then we're talking about a minimum. Sometimes I refer to this as this. When you're in a bad mood, you have maximum worries. Okay, so when you have a frown face, usually you have maximum worries. When you're in a good mood and you're smiling, you usually have minimal worries. And so that's a good way to remember it as well. Or you can just use your logic and see that it's the very top. That means maximum. The very bottom means minimum. So I would click on maximum at this point. Then it says, what is the max and where does it occur? So I need to find the vertex. The vertex tells me where the max and min occur. How do we find the vertex? Good review. It's the opposite of b over 2a. That's how you find the x value. How do you find the y value? 4ac minus b squared all over 4 times a. And so we just simply need to find those values. And so we go ahead and we go the opposite of b, which is 36, all over 2 times negative 3. We end up getting negative 6 as my x value, and so that is where it occurs. What is the y value? I could plug negative 6 back in for x, or I can just simply do this. And we have 4ac, woo, that's a big number there, minus b squared, ooh, that's a big number there, so I hopefully have my calculator here handy, and then all over 4 times a. So plugging it back in wouldn't have been a bad thing. Or you can just use a calculator. And that's what we're going to do, is we're going to simply use a calculator. Excuse me, I had to go get it. And so what we have is we have 12 times 106. And so we get 1272. I'm going to write down here, and I'll erase all this once we're done. 1272 is what we get for negative 12 times negative 106. Negative 36 squared ends up being 1296. And then on the bottom, what we end up getting is negative 12. And so again, what we do is do some arithmetic, and we would subtract 1296 from 1272. We get negative 24 divided by negative 12. And wow, imagine that. It worked out so nicely. And so there's our y value. And so what is the maximum? The maximum here is 2. This is the max. Where does it occur? At negative 6. Okay, and that's our x value. So if they said, what is the max or min, you'd put 2. If they said, where does it occur, you'd put negative 6. In this case, it says, find what that value is and where it occurs. So it's asking for both. Okay. Now, if you look at the one right below it here, we have f of x equals 12x minus 13. Now, what do you notice about that? Well, hopefully what you notice is this isn't a quadratic. We don't have a second degree polynomial. This is actually a line. Okay, if we graph a line, this is going to have a y-intercept of negative 13, then we go up 12 over 1. The question is where's the very top of this line? The arrow sort of implies it goes on forever. So it doesn't have a max, and the arrow implies it goes on down here forever. So in other words, this line neither has a max or a min. So in this case, if I got that problem on the exam or on the assignment, I would click neither, because it neither has a max or min. It needs to be a parabola, a quadratic, in order to have a max or min. Now if we move on and take a look at some actual application problems here. Okay, let's look at this one. It says among all rectangles that have a perimeter of 106, find the dimensions of one whose area is largest. Maximum. Okay, it's another word there. Write your answers as fractions reduced to lowest terms. Okay, so here we go. Rectangles. So here we go. I'm going to draw a rectangle. I'm going to call this side x, and I'm going to call this side y. Okay, so this side over here would be x, and this side would be y. We'll see if we need it. So it's among all rectangles who have a perimeter of 106. So the perimeter is 106. So notice they gave you something. This is something we know something about. That means it's secondary. We know something about the perimeter. Now, how do I find the perimeter of a rectangle? Hopefully you remember it's the sum of all the sides. And so in this case, I have x plus x, which is 2x, and y plus y, which is 2y. So the perimeter is 2x plus 2y, and that should equal 106. And we could reduce this by dividing everything by 2 if you wanted to. That'd be fine. This right here is called our secondary equation. It's something we know something about, and we're going to end up using it in the primary equation. Now, the primary equation is what we're trying to find the max or min of. They didn't ask us to find the maximum perimeter. It said find the dimensions, which, okay, so we need to know what x and y are. That's what we're looking for. Of the one whose area is largest. So they're trying to maximize the area. Well, how do we find the area of a rectangle? Hopefully you remember it's x times y, or length times width. And so there we go. What we're trying to do is find the maximum of this product. So to do that, I have an x and a y, and I don't want an x and a y, I just want one or the other variable. So what we can do is go back to our secondary. Isolate a variable. I'm going to isolate the y by subtracting x. So this thing in the blue is what y is. Y is 53 minus x. I can now replace y with 53 minus x. I use the secondary in the primary, and now look what happens. Now instead of having two unknowns, I really just have one unknown. The x is all I have here, and the a is like the function's name. So if I distribute the x through, I have 53x minus x squared. That's a quadratic. How do I know that? It has the quadratic term. The x squared gives it away. If it has an x squared, it's quadratic in this case. We go ahead and we want to find the vertex. Okay, and so we go, well, okay, the vertex is the opposite of b. Now, let's rewrite this real quick, just to make sure we find the correct a, b, and c. The c is actually 0. If you notice, there is no c there. And so our a is -1. Our b is going to be 53. And then our c is 0. So what I want to do is I want to find the vertex. I want to find the x value of the vertex. That is what's going to produce, okay, that's going to be this x right here. Now this y, I'm going to find by back substituting in the x. So this y is not the same thing as the y value of the vertex. This is the y value of the rectangle, okay? What we want to do, and this x right here is the x value of the rectangle and it's the x value of the vertex. So it's both. That's why we want to find the x value of the vertex. So it's the opposite of b all over 2 times a. And so what we end up getting is whatever 53 over 2 is. And so I think it's 26.5 is what our x value is. And so what we have is we have 26.5 as our x value. And what we want to do is we want to go ahead and we want to figure out what the y value is. Well, okay, so here you go. You know what the x value is. That's one of our dimensions. Okay, and you can look at this as 53 over 2. It's fine. But 26.5. That's our x value. And what's our y value? What's going to be our dimension here of our y value? Well, what we want to do is we want to take our x value and back substitute into the secondary equation. I'm actually going to get rid of this a little bit. There we go. So we have a little bit more room. So what we want to do is we want to take the x value you just found in the vertex and we're going to plug it into the secondary equation. Okay, so let's review here. What I did is I drew a picture if I needed one. I identified the secondary equation. That's what we know stuff about. Then I identified what we're trying to find the max or min of because that's called the primary equation. I'm going to use the secondary. I'm going to isolate a variable in the secondary so that I can substitute its value into the primary. Hopefully that produces a quadratic. That's what I'm looking for. I find the x value of the vertex, which is the opposite of b over 2a. So it's 26.5. And now what I'm going to do is I'm going to back substitute into the secondary equation. Okay? So I'm going to back substitute into the secondary equation to find my y value. So in other words, y should equal whatever 53 minus x is. Well, what's x? 26.5. And what you'll notice is, once you do the arithmetic, what you also get is 26.5. And that actually makes really good sense, because to maximize the area of a polygon like this, you would want to make it a square. And so in this case, that rectangle is actually a square. And you get 26.5 times 26.5 is the dimensions, or by 26.5. Now, if they said, what is the maximum area? They didn't. They said, what are the dimensions? So they're asking for the x and the y. But if they said, what is the maximum area? Then what you're going to do is you need to figure out if x is 26.5 and y is 26.5, what is the product of those two? And you would multiply them, and that would tell you what the maximum area would be. So you can see how important it is to read the directions very carefully to solve these. Now I'm going to go ahead and do the one that I just sort of vanished here. I'm going to erase all this. So again, pause it right now if you need to write some things down, whether it's on your notes or whether it's questions. Make sure to do that at this point. I'm going to go ahead and move this one up, and we're going to take a look at this one right here. And so let's look at this second problem. And it says the back of Jane's property is a creek. Okay, so we got a property, a house, or whatever. And then back here we got water. It's apparently red water. Okay, so we got water here. Jane would like to enclose a rectangular area using the creek as one side and fencing for the other three sides to create a corral. And so she may have some animals or something, or whatever it is. But what she has is she has this area right here. Is what she's trying to. That's her land. So we have water here. We got this rectangular area, which is her land. So again, I labeled this x, I'll label this y, and this is an x. But we don't have a y over here because she didn't have to use any fencing. She's saving money. And so that's a smart thing. Then it says if there is 140 feet of fencing available. So let's say she had 140 feet of fencing just laying around. She put fencing around her house or around her property, and now she wants to she has some leftovers, and she wants to do this rectangular thing for her dog or her chickens or whatever it is. Now she can do this with 140 feet. Now notice, that's something we know about. She has 140 feet of fencing. I wonder if that has something to do with the secondary equation, because we know something about that. Okay, now let's do the primary. Okay, so that's we'll get to the secondary here in a moment. Let's go to the primary. That's one that we got to end up changing to find our max or min. It says, what is the maximum possible area of the corral? Okay, how do we find the area again? Well, it's xy. So this one again, our area would equal xy. So I need to find a secondary, though I can do what we just finished doing. To do that, though, my perimeter, like the last one we had a perimeter, it was 2x plus 2y. But we don't have two y's, we just have two x's and one y. But wouldn't that be perimeter? If we put up 140 feet of fencing, that would be the perimeter of that corral, other than the water. So really it's the perimeter minus one of the long sides. So what we have is we have two x's plus one y should equal the 140 feet of fencing. She didn't use any fence here. So she had 140 feet. So x plus y would be 140. Now we have a secondary, we have a primary. Now what are they asking me to find? What is the max? So they want us to know what this is. So they're looking, I'm going to put a box around it. They want to know what that is. So to do that, I've got to find an x and I've got to find the y. In order to find the x and y, I use the secondary. I go ahead and subtract maybe 2x. Now I know what y is. I substitute in for y. I get x times y, but y in this case is 140 minus 2x. I distribute. There's my quadratic. And now we can go ahead and find the vertex, the x value of the vertex, which is the opposite of b. Our b is 140. Don't let the order confuse you. All over 2 times a, which is negative 2. So we end up getting negative 140. Woo. Let's try that again. Negative 140 divided by negative 4. And if you type that into a calculator, or however, you're just going to reduce it, so that you really need to do. But 140 divided by 4 ends up being 35. So our x value is 35. So we know what the x is. How do I find the y value? Well, to find the y value, I back substitute this into the secondary. Remember, that's what we know stuff about. And so I come right up here and I substitute into the secondary. So you use the secondary in the primary to find the x value of the vertex. Then you take the x value of the vertex and you plug it into the secondary in order to figure out what the other value is. So we end up getting 140 minus 70, which in this case is 70. And there we go. Now that's not our answers. 35 comma 70 is not going to give us the right answer. They're asking for what is the area. Remember, I put a box around it? This is what they're asking. So now I need to multiply the x and y. So my area that is maximum is going to be 35 times 70. And so I do 35 times 70, and what you end up getting is 2450. And in this case, it's going to be squared feet. But that would be going to be the area that maximizes that corral. Okay? And so that's good to know. And that's how we end up doing it. Really a perimeter problem, and then also a perimeter problem just with one of the sides missing, and then numerical problem as well. If we move on and take a look at a few more examples, let's go ahead and look at those. And I'm going to work a little quicker on these now that we sort of have the idea. I'm going to have these vanish, and we'll bring them back up in a moment, but let's just do one at a time. So let's take a look at the first one. Among all pairs of numbers such that 2x plus y equals 11. Ooh, we know something about that. Look at that. Isn't that just a secondary just sitting there? You don't even have to find it. Find the pair whose sum of squares, and they give it to you. Awesome. They give it to you as minimum. So they give you the primary. That's what we're trying to find the max or min of. In this case, the minimum. My minimum is going to be x squared plus y squared. That's going to be our function, okay, or whatever we want to call that. Okay, that's going to be what we're trying to find the max or min of. We're going to use the secondary. We're going to isolate the y again. That would be a good one to isolate. So 11 minus 2x. And now I can substitute in what y is. I get x squared plus quantity. Be careful here. Make sure to square the quantity, not the term. So I've got a FOIL. Expand this out. So I go ahead and I'm going to have 11 minus 2x times 11 minus 2x, a binomial expansion. You end up getting 121 minus 22x minus 22x plus 4x squared. Combine like terms, and you end up getting 121 minus 44x plus 4x squared. Combine a couple of like terms. There it is, 5x squared minus 44x. Just reorder it a little bit. 121. There's our function. What do? We find the x value of the vertex, which is the opposite of b, all over 2 times a. And guess what do we get? 44 over 10. And you can reduce that to 4.4 if we want to leave it as decimal. Or you can reduce the fraction down. I mean, you can take a 2 out and leave it as 22 over 5. These are equivalent. But that would be your x value. Now it says find the pair. So we know what the x is. It's 22 over 5 or 4.4. What we need to do is we need to find the y value that satisfies this. Well, how do we do that? We plug this value, whether it's this one or this one, doesn't matter. We plug those back into the secondary equation. We plug it into the secondary equation. We plug it into the secondary equation. So if you want to do the decimal, that's fine. 11 minus 2 times 4.4. What we get is 11 minus 8.8, which ends up being, in this case, 2.2. Now, 2.2 is 2 and 2/10, which is 2 and 1/5, or 11/5 is what that is. And so you can either write it as a fraction or as a decimal, depending on what the directions say. It says write your answers as fractions, reduce the lowest term. So I'm glad I wrote it as a fraction. That's why we read the directions. I'm glad I looked up there and saw that. But 11 over 5 and 22 over 5 are your 2 values for the x and the y. Okay, let's move on to the next one. Okay. The next one that we have is going to look like this. I'll move it to the top. And let's see what we got going on here. It says the total cost of producing a type of boat is given. So notice they gave you a cost function. That's the cost it is to make a boat, I guess. Where x is the number of boats produced. So x is the number of boats. C is the cost that it costs a company to produce these. How many boats should be produced to incur minimum cost? So we want to find a minimum. Okay, so what do we find the minimum of? Cost. What is cost? This. So this is your primary, because that's what we're trying to find the max or min of. What's our secondary? Well, okay, we really don't need a secondary, because look at your cost function. Isn't that a quadratic? So we simply need to find the vertex of the quadratic. So it's the opposite of B. Now notice the order here. This is your A, this is your B, this is your C. Okay, so the opposite of B is going to be 40 all over 2 times A. So we get 40 over 0.4. And when you divide this 40 divided by 0.4, you're going to get a nice looking number for your x value as 100. Okay, so your x value is 100 is what you get. Now, if the x is 1, that's how many boats are produced. And that's what they're asking. How many boats should be produced to incur a minimum cost? X is the number of boats produced. And the x value vertex is that. We just solved it. It's 100. Wow, that wasn't too bad. That was really actually pretty easy. Hopefully you saw the same thing. Okay, let's take a look at the third one. Okay, now, obviously in all these problems, please pause, work them out yourself, see if you can't figure it out before I get all the way through them. So pause it right here, work this one out and see if you can get it. Okay, but here I go. The rancher has 800 feet of fencing to put around a rectangular field and then subdivide the field into 2 identical smaller rectangle plots by placing a fence parallel to one of the fence shorter side. Woo! What's going on? Well, he's got a rectangular field, but he's going to put another fence right in the middle. So he's going to have 2 identical sort of rectangular areas here. So if we call this x, and this is x, we call this long side y. This one in the middle is also x. We call the long side, let's call it y. And we call this side long side y. So that way we sort of have no idea what's going on. It says find the dimensions that maximize what? Area. How do we find the area of this polygon? Well, the area of this is no different than if the middle wasn't even there. It's going to be our length times width, right? So x, or in this case, x times y is what we'd have as our area. So that's your primary equation. Now, okay, our secondary equation. Okay, what do you think? Well, notice he had 800 feet of fencing. That's something we know about. So he built this using 800 feet of fencing. So in other words, if I added up all the sides, it'd be 800. Let's just do that. But in this case, instead of 2x, we have 3x plus 2y equals 800. Yay. That's called the secondary equation. We use the secondary in the primary by isolating one of these values. So let's go ahead and do that. I'm going to go ahead and get, again, y by itself. You can get the x by itself, but I like the y by itself. So we get here, and then we go ahead and divide by 2, and that's our y. And so this right here is our y value. So now I can replace that with a y. Now you can go ahead and you have an STD, you can stack and simplify, however you want to look at it. But now your area looks like this. The area is x times, let's go ahead and I'm going to divide 800 by 2 and then my 3 by 2 as well. That makes it a little easier. And then I go ahead and distribute my x. I get 400x minus 3 halves x squared. It made it a little easier because now I know what my a and my b are. Now let's see what they're asking. It says find the dimensions. So I need to know what x and y are. So my goal is to figure out what is x and what is y. So that's what I got to figure out. Now the x value comes from the vertex. It's the opposite of b all over 2 times a. So again, some practice. This is our a because it's right next to the quadratic term. This is our b because it's right next. It is the coefficient of our linear term. Excuse me. And so what we have is a negative divided by a negative is a positive. 2's are going to cancel, and so what we end up having is 400 divided by 3. And you can just leave it 400 over 3. Let's see what they say. Write your answers in fractions. Yeah. So 400 over 3. It's like 133 and a third. But 400 over 3, there we go. There's our x value. Now, if I wanted to find the y value, what do we do? See if you can remember. Okay, I hope what you're saying is take the x and plug it back into the secondary equation. That's how we find the y value. What is y equivalent to? Isn't y right here? Look right there. Isn't that our secondary? Okay, so if I take this x value and plug it in right there, it should tell me my y value. And so I get 800 minus 3 times 400 over 3. Ooh, that works out nice. All over 2. 3's cancel. You get 800 minus 400, which is 400. And what's 400 divided by 2? Well, that should be 200. And so there we go. There's our dimensions, 400 over 3 by 200. And that's how you find the, in this case, the maximum area is with those dimensions. Okay, going on to the next one. Here we go. Last one, I believe, for this page. Okay, among all pairs of numbers, the sum is 244. Okay, this is something we know about. Secondary. Ooh, sum. So I have a pair of numbers when I add, or 244. I don't know, maybe just, there we go. Add two unknowns equal 244. That's your secondary equation. That's something we know about. Find the pair whose product is maximum. Okay, so I'm going to use x and y. Product means multiplication, and this is what I'm trying to maximize. So this is my primary. That's what I'm trying to find the maximum of. So what do? It's like a broken record. I take the secondary, I substitute in a value, let's say for y, from the secondary into the primary. This should result in a quadratic, and if you notice, we do get 244x minus x squared. And then what I do is go, okay, it says find the pair. So they're asking for the x and the y. So I need to find the x, which is the opposite of b, all over 2 times a. Okay. And what we end up getting is 122 for my x value. How do I find the y value? I substitute the x value back into the secondary equation. Where's that at? Boom, right there. And just label. And so I get 244 minus 122, which is again 122. And we've said that's going to be true because this is a lot like the perimeter one. When I added things up and I have a product that I'm trying to maximize, a lot of times a square, in this case 144, or 122, I put 144 twice, sorry about that. 122 for both of them would be your dimensions. Okay? And you can multiply those two together if you wanted, or if they're asking for what is the maximum product. You can multiply the 122 and the 122. Okay, last couple problems here, and then we got a doozy coming up. I know there's a lot of examples here, just hang with me. And again, you can pause it, you can fast forward or whatever if you feel like you're getting it. A projectile is launched upward with a velocity of 256. Okay, we talked about this. First off, if it's upwards, that means it's a positive 256, and this represents your v sub o. That's your original velocity. So we talked about this back in the earlier chapter 2, about this formula. Negative 32, remember it's negative 1/2 gt squared. Well, g gravity is negative 32, or 32. And so that's where the negative 16 comes from. This is just a projectile, function for projectiles. This is gravity, this is time, this is the original velocity, this is your original height. Anyways, that's going to be given to you. You just need to make sure to label things correctly. So v sub o is 256. So I have negative 16t squared plus 256t. And then it says from the top of a 70-foot platform. Hey, there's my height. Okay, so there's my starting height, that's my ending height. So my starting height is 70, my ending height is h of t. It says, what is the maximum height obtained by the projectile? So what they're asking me for is they want me to maximize the height. Well, to do that, I'd find the x value of the vertex. So the opposite of b, all over 2 times a. Man, doesn't it sound familiar? So you get negative 256 over negative 32. Two negatives make a positive, and if you do 256 divided by 32, what you end up getting is 8. And so when x is 8, and this is your height. What is the maximum height obtained by the projectile? Well, this is your time, is what we're looking for. That's what we just found was t. Remember x, we used x before, but this is t. So in 8 seconds, we have reached our maximum height. Now, notice it didn't say when does it reach its maximum height. It said what is the maximum height. So this produces the height. This is like your x value, even though it's t. So we're going to take the 8, and if I want to know what the y value is, what the height is, I need to go ahead and plug it in right here. This is my t for that given time. And so you would go ahead and you would get, you would multiply, and you get negative 16 times 64, and then you would add 256 times 8, and then you would have plus 70. And when you hit that, you get 1094, and that would be in feet. Okay. I don't know why I put an equal sign there. Let's get rid of that. And so there we go. 1,094 feet is its maximum height. And again, how did I get that? I took the 8, which is the time. The vertex, I know this is the x value, the vertex, but it actually represents t in this problem because we changed the variable. But this is the x value. It's what produces the height. How does it produce it? By plugging it back in. This will tell me what the maximum height is, which is 1,094. Looking at the bottom one, the revenue function of a mower shop is given. X times P of X, where X is the number of units sold and P of X is given. Notice they gave you P of X. You don't have to find it. Awesome. So simply plug in what P of X is. So you distribute, guess what we end up getting? We end up getting a quadratic. And so probably we're going to find the vertex of that, so it's the opposite of B. All over 2 times A. And so we end up getting 200, because a negative over a negative is a positive, and 200 over, in this case, 2 times 1/2 is just 1, so we end up getting, in this case, just a positive 200. Now, let's see what they're asking. Find the maximum revenue. So the X value is how many units have been sold. That's 200 units sold to maximize the revenue. If I want to know what the maximum revenue is, remember, this is your revenue function right here. We need to plug the 200 into the X. Or, what's even better is just plugging it right here. Okay? And so what we have is we have 200 times 200 minus half of 200 squared. And so we go 200 times 200. And so you end up getting 40,000. And then what you have is 200 squared. And then what you do is you take half of that, or multiply it by 0.5. And then you get 20,000. And so if you subtract those two, you end up getting 20,000. And so that is your revenue. That's pretty good. I'd take 20,000. And so as a lawnmower shop, if you sold 200 units, that would maximize, if this was your revenue function. And what is the maximum revenue? 20,000. Okay. All right. Last one, put your big boy pants on. These are tough. You don't have a lot of these, but you will have one on your assignment, maybe even one on the test. I want to show you one, and then show you a second one. Hopefully you can work these out. It's a cruise ship problem. Okay, so when you see the cruise ship problem, it's the big boy pants. Okay, now what we have is we have a cruise ship that can hold up to 66 people on a 3-day excursion to and 46 or more. Okay, so it goes from 46 to 66. So 46 people, 47 people, dot, 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 and then all the way to 66. Now, notice if the group contains 46 people, each person pays $78. And so we could find how much, and then each person over 46, it's $1 less. So $1, it reduces by $1 for each person who exceeds. So in other words, we would have $77 here, and then $76 for 48, and so on. Well, notice it's 20 people, and so it's $20 less. And so it would be like 58 or whatever down here. So we could list them all out, and we can multiply every single one of them and figure out which one is the biggest, because that's what we're looking for, is the maximum. No, we got to do this mathematically. Okay, how do we do this? Well, I'm going to label these things. Okay, I'm going to label the number of people, X, and the dollar amount, Y. Okay, so let me put it over here. X, number of people, and then Y is the dollar amount. How much it's going to cost, okay, each person. So notice what we have is we have a primary equation is X times Y. That's going to tell us how much our income's bringing in. Okay, so X times Y is the income. And we want to maximize that. So I need a secondary equation. Now this is where it gets a little tough, but what we need to look at is this. If you look at 46 and 78, if you add those two, 46 plus 78 is 144. Okay, so if you just look at it as an addition. I know we're multiplying, but if you added those, it's 144. Notice if I added 1 to 46, I get 47, and I took away 1. An addition of 1 and subtraction of 1 cancel each other out, and guess what we get as a sum? Still 144. So there's a pattern here, that whatever two numbers we have, they're going to add to 144. So if you think about it, instead of using 46, 78, and 47 and 77, let's use X and Y. So in other words, X plus Y has to equal 144. Now what you're going to do is you're going to look for that same type of pattern on all these other cruise ship problems. So when we get down to the bottom one, it's going to be the same thing. It may not be 144, but it will have something very similar. Now we have a secondary equation. Go ahead and isolate your Y. And now what we have is what y is. I can substitute it in. It's like a broken record. I mean, we just keep doing the same thing. I get 144x minus x squared. Find the vertex, which is the opposite of b, all over 2 times a. And so what we get is we get 72. 72 is our x. That's how many people. Now notice what they're asking. Find the size of the group. That's it. Found it. If they said, what is the maximum income, I would do 72, and then I'd have to plug that back in to find the y, or back into my function right here to find my income. So it would be right here. And so I'd plug that 72 in if I wanted to find the maximum income. But really, I answered the question of 72, find the size. Okay, now pause it. Make sure you get that down, rewind it, watch it again. And let's take a look at this bottom one. Same kind of problem. But the difference is now it holds up to 56 people. Okay, so this cruise ship holds up to 56. 38 or more. So again, we can go through and then how much does each person get charged? Well, it starts, each person gets paid $56 to start with. And then notice this one goes down 1 every time, so 55 and so on. And then it's the difference from here to here is 18. So if I subtracted 18 from 56, I end up getting 38. Now let's see if it makes sense. Now remember, what we did on the last one is we called this x, we called this y. So let's do the same thing. X is the number of people. Y is the cost, so it's the money. Okay. My primary is xy because I'm looking for my income. Okay. I need my secondary, so if I look here and I add these, I know we're multiplying to find the income, but if we add them, what we get, because the secondary doesn't have to go with the primary, it could be just something else. If we add these, what we end up getting is we get 94, I believe, every single time. Okay, every time. So in other words, instead of using the numbers, if we use x and y, wouldn't it be safe to say x plus y should equal 94? Now what we can do is we can go ahead and isolate y, 94 minus x, substitute that back into the primary, 94 minus x. Does it feel like you're doing the same things over and over? I hope so. That's the point. Find the vertex. Find the x value of the vertex. So it's the opposite of p, all over 2 times a. And so we get 94 over 2. What's half of 94? Well, it's going to be 47. Now, let's see. Now, 47 represents our x value, which is people, right? X is the number of people. Let's see what they ask. Find the size of the group that maximizes it. They found it. 47. If they ask for what is the maximum income, I would plug it into my income function, which is right there, and that would tell me my maximum. So those are a little bit of boogers. Hopefully you're able to figure those out, and from these examples, utilize them, and ask any questions in class if you have them.